Okay, so hello. Welcome sa session natin today. This is our last physics lesson na, no? For our program. I could have discussed more, kaya lang, yun nga, that's our allowed period lang, no? Yung 31, unless you want more, no? Pero ito, here's what we're going to discuss today. Dynamics, no? Diba dati, kinematics, ayun, dynamics na. It's the upgraded version, no? And it focuses on the system or on the forces. Bale, forces yung pag-aaralan natin today. Okay, game. So, let's start. Forces muna, no? So, force is defined as a push or pull, no? Push or pull. You might know na mass times acceleration ang force. Pero, yes, there's more than that, no? Sige, game. Let's see. A force is defined as, bukod dito, no? Force is defined as an interaction, no? Any interaction between an object and its environment, no? And vector din siya, no? Vector siya. Diba if you remember our first discussion on scalars and vectors, ang nating vector ang force, no? Force has a unit of Newton. Then we have some common kinds of forces, no? First, when a force involves direct contact between two objects, we call it contact force. So, ito, example. Yan, contact force yan kasi pinush niya, no? And ito rin, no? Contact force din yan kasi kahit pa paano, pinul niya, no? With contact. Then, yung mga kinds of contact forces natin, we have the normal force. I don't know if... Oh, wait. I have a question. Have you tried... Nakapag-discuss na ba kayo ng force kahit pa paano nung grade 8? Or hindi pa? Notes for fourth quarter. Ginagawa. Okay, sige. At least, kahit pa paano, meron kayong idea what the force is. Kumbaga, these will be familiar to you, I'm sure. So, common kinds of forces, normal force, contact force exerted by a surface, no? Always perpendicular to the surface. Always perpendicular siya sa surface of contact, no? Yan, example, yan ang normal force niya. Ito, yan yung normal force niya. Para pagpaganyan, tas may object tayo dito, yan yung normal force niya. Okay? Parating perpendicular, no? Parating perpendicular, as you see. Okay? Tapos, as you'll see later, normal force is not always equal to the force due to gravity or your weight. Okay? That's one thing I have to tell you. As you'll see later naman. Next, friction. Friction, no? Kaya may friction para ma-oppose niya yung movement, no? Para hindi mag-slide to keep it moving, to keep it stable, no? Kaya may friction. In other cases, para hindi gumalaw at all, no? It is a contact force exerted by a surface on an object in which it is in contact with, no? It acts parallel to the surface of contact, opposite to where the object is moving. So, kita nyo naman sa figure ko, diba, pag ganito gumalaw yung object, pag ganun siyang gumalaw, diba? So, yung friction niya, the other side, opposite, no? Opposite, the other way around. The normal force niya, perpendicular, diba? Perpendicular siya. There. Kung ang normal force perpendicular, ang friction parating parallel sa ginagalawan niya. You'll see later that there's a relationship between these two. No? Oh, by the way, remember yung mga terms na sinasabi ko sa inyo kasi this would come a lot mamaya sa mga problems natin. And, ayun, visualization is required again, no? Imagination, para madali nyo maintindihan to. Okay, sige, next. Tension force. Pulling force exerted by a stretched rope or cord on an object to which it's attached. Yun. So, tandaan nyo, yung direction ng tension, it's always toward the puller, no? Kung saan ina-apply ng tao yung force, doon siya papunta. Example, nandito yung kamay ko, nandito yung cord, no? Nandito yung cord. Tapos gumagalaw papunta sa right yung tao. Yung tension force ko, pag ganon. Okay? Parating papunta sa tao, no? Ganon parati. Okay? Always remember that. Sige. Kumbaga, palabas sa kanya parati, no? Palabas sa kanya. Okay? Always remember that, ha? Next. Tapos, other kinds of forces naman. Ang long-range force acts when the objects are separated by empty space. Example nito ay gravitational force or weight. Yun na naman yung example natin for this. Force due to gravity that pulls an object towards the center of the earth. Yan. Weight. Hindi siya pareho sa mass, ha? Remember. Hindi siya pareho sa mass. Although, ang tawag sa, di ba, sa mga medical records, so that height and weight, actually mali yun eh. Dapat mass. No? Mass yung nandun. Then, okay. Next, important concept to, free body diagram is a diagram that shows all forces acting on an object. There's no steps kung paano gumawa ng free body diagram. Basta, it is important to take note all the forces that are acting on an object. Example, dito, weight, di ba? Ayan. Kumbaga, take a point, yan, kahit dot lang, drawing ka na. O yan, weight. Tapos, force of the block on the runner. No? Kasi di ba, ayun, no? Kita mo yun? May block doon eh. You'll see later kung bakit may ganyan, no? Ayan. F. Yan, ganun lang kasimple. O kapag nag-swimming ka, ito, mga other kinds of force yan, pero we won't go with that na, no? Example naman, pag sinabi nag-swimming ka, tapos sinabi sa problem, gumagalaw ka towards the right, tapos sabi, yun, nag-swimming ka nga, no? Weight, buoyancy, force to make you float, drag, force opposing you, moving forward, tas thrust, no? Force that, ayun pala. Hello. Sorry. Teka. It's okay. Wala pa naman ako di-discuss na calculation, no? Wala pa naman di-discuss na calculation. Tsaka lahat ng dinaanan ko kanina, madadaanan natin ulit, no? So, I'll just proceed forward. Pasensya na, kasi, yeah, we're running late. Okay, sige. Drag force, no? Drag force, papunta doon. Tas thrust, dapat thrust yung papunta dito. Force that propels the person forward and drag the other way around, no? Other way around. Okay? Sige, next. Ito, example, isa pang example. Don't worry, we will discuss later how to make free body diagrams, no? Yan, example, looking at itong box na to, and ang pag-drawing ng free body diagram, di ba, example, may dalawang objects sa system mo, it's per object, no? Hindi pwedeng dalawang object sa isang free body diagram. It's okay, we'll discuss more of that later, no? So, yan, example, A, let's look at A. Yan, may tension, kasi doon naka-attach yung string, no? May tension. Tapos, para hindi siya mag-slide papunta doon, kailangan ng friction, no? Kailangan ng friction. Next, may weight. Tapos, merong normal force, syempre. Okay? We'll discuss more later. Tapos ito, superposition of forces. Nothing special here. Basta alam natin na ang force ay vector, and to get the resultant force or net force, we add all the components of your force, no? The same way we did last time. I hope you remember. So, yun lang, the same thing, no? Net force is just the sum of all the forces acting on an object. The x component, you may cosine. Y component, you may sine. The resultant is this. The tangent theta is the angle, no? Angle with respect to the horizontal. Ang angle sa forces parating with respect to the x-axis, no? I hope you still remember our previous lesson on this. Yan, yun lang siya, no? Yun lang siya. Same as before. Sige, demonstration. Ako muna, no? Ako muna. Sige. Look at the whiteboard na lang, no? Example, tinanong sa atin yan, no? What is the net force on the wrestler? Yan, free body diagram na yung nakita nyo dyan. No? Free body diagram na yan. Okay, sige game ha. Just look at the whiteboard. Okay, game. Para ma-refresh din kayo. Oh, 3 professional wrestlers. So, let's just draw the blood diagram, no? Teka, may mali sa diagram. Okay, game. Yan, F1. F2. Yan, free body diagram yung tawag dito, no? Pwede ng free body diagram. F3. 50. 120. 250N. Find the resultant force. Diba? Find the magnitude and direction of the net force. Sige, game. X component, no? X component. Ito ay 53. Sige, I hope you still remember, no? X component natin is 50 plus 250 to, diba? 250 ay minus siya kasi diba nandito yung X natin. So, dapat negative. 50 minus 250 cosine 53 equals to negative 100. Let me fix nga pala yung whiteboard para mas maintindihan nyo siya. Ayan. Next. Y component. So, we look at the vertical. Ito lang, no? 120, tsaka yung sign nito. Take note, ito, pababa. So, dapat negative 120. Tapos ito, pataas siya. Plus 250, sine 53. Kaya ako kayo pinag-aral ng vectors kasi hanggang ngayon, ginagamit pa siya. Equals to 80, no? So, the resultant is square root of x squared plus y squared. We just get the squares of each, then add them. Equals 128 newtons, no? Yan yung resultant. This is the magnitude. Ano yung direction, no? Ano yung direction? Oh, y over x. Negative yung x, positive yung y. So, dapat nandito yung angle. Nandito yung angle, no? So, sige, let's get the negative. Let's get the direction. Theta equals tan, negative 1, ry over rx. Substituting, we get negative 39 degrees. Negative 39, pero dahil paganto siya, di ba? So, subtract lang natin, move 39 degrees, clockwise, no? So, we will get 141 degrees, no? 141 degrees. Yan. Nakuha ba before I continue? Same principle lang as before, no? Nakuha ba before I continue? Sige. Ayan, if you have questions, please type lang sa chat, no? Parang online class lang. I'm sure that's how they do it sa online class. Okay, sige. Game, para masanay din kayo, no? Okay, next. Ngayon, let's go back to our PowerPoint, no? Please tell me if gets nyo or hindi, Please, sabihin nyo sa akin. Chat nyo lang ako pag hindi. Okay, sige, next. Ito. 3 laws of motion. I'm sure na na-discuss na to sa ilan sa inyo, no? So, it's just kind of a review, no? It's just kind of a review. And I think this time we're going to have a deeper study ngayon sa grade 9, no? Okay, game. So, law of inertia. An object acted on by no net external force has a constant velocity, which may be zero and zero acceleration. So, tandaan natin, ang object, no net force, or kaya zero yung force sa kanya kapag di siya gumagalaw, or no acceleration, or constant yung velocity ng paggalaw niya. Okay, always remember that. Then, the law of inertia states, or the first law states that an object will continue An object will continue to stay at rest or continue moving at a constant velocity. Take note, constant velocity. Kasi pag hindi constant yung velocity, mayroong acceleration. And therefore, may force na nag-act upon it at a constant velocity unless a net external force acts upon it. In short, an object that continues to stay at rest or continues to move at a constant velocity in a straight line is in equilibrium. Equilibrium tawag doon, no? Ito, yan yung sabihin niya. Yung sum ng forces ay zero, no? Always remember that, no? You use that a lot later. May mga example dito. Saan natin nakikita yan, no? Saan natin nakikita yan? Example, itong bato na malaki. At rest. So, wala namang gumagalaw sa kanya. So, hindi siya gagalaw, no? Pero ito, example, meron dalawang taong magkasing laki. They push the same way, as in exactly the same way, oppositely, sa rock. Hindi siya gagalaw kasi balance yung force niya, no? Balance yung force niya. Okay, next. Ito naman, kapag naman nagsama na yung dalawa, papunta sa isang direction, gagalaw doon. Magkakaroon ng acceleration papunta sa kabila, no? Okay, next, football. At rest. Siyempre, gagalaw lang naman yung object kasi may unbalanced force, no? Which is your kick. Gagalaw siya dahil sa kick mo. Then, it stays in the air unless ma-stop siya ng net, di ba? An object acted upon by an unbalanced force from the net changes speed and direction, di ba? Bounce back na siya. Yun, di ba? Next, what else? Yung mga seatbelt nyo, guys. Yung mga seatbelt, no? Kung pansin nyo sa sakyan, diba, pinagsa-seatbelt kayo. Bakit? Bakit importante yon? Kasi kapag gumalaw yung sasakyan, gumagalaw rin kayo. Yes, of course, gumagalaw rin kayo. Hindi nyo na lang nararamdaman kasi you're moving with the car. You're moving relative, no, to the car. So, hindi nyo siya masyado nararamdaman. Next, bigla kayong nakasagasa. Diba, ano yun? It stops the car. Provides an unbalanced force to stop it. So, stinap niya yung car mismo, pero kayo hindi. 'Di ba? Hindi kayo masastop. Kasi hindi naman kayo nakadikit sa car eh. Nakaupo lang kayo, you're just simply placed on top. Kaya pag wala kayong seatbelt, lilipad kayo tulad ng tao na to. Ayun na, kaya always remember, sa kotse, always wear your seatbelts, no? Kasi they're very important. Next, the tendency of an object to maintain its state of rest or uniform velocity in a straight line is called inertia, no? This is how if you know this instrument, that's how it exactly works, no? Due to the law of inertia. Mass is the measure of inertia in an object. Siyempre, the higher the mass, the harder it is to change its state. So, kaya napapansin siguro, ang hirap itulak ng kotse kaysa sa bola, diba? Kasi obviously, mas malaki yung inertia nung truck ay ng kotse, hindi siya mapupush agad, di ba? You'll see more later kung bakit ganon. Oh, see? Yan, see, ayan pala yung diagram ko. See, pag mas baba yung mass, mas change yung state ng object, diba? Mas mabilis tong gumalaw kaysa dito. As seen by the acceleration vector, no? Mas malaki yung acceleration vector ng bola kaysa nung kotse. Yan, that brings us to our next law. If a net external force, ibig sabihin may net force na nag-act sa object, the object accelerates. And the direction of the acceleration is the same as the direction of the external force, of the net force, no? Mass times acceleration. Dito yon pumapasok, no? Dito pumapasok yon. In short, a net force causes acceleration. No, ito, example. Kung zero yung, example, naglalaro tayo ng hockey, no? Ng hockey, ice hockey. If there's no zero external force, so zero kamo yung force, ayan, no? Tuloy-tuloy lang siya, no? Same velocity across the ice, assuming na walang friction, no? Nagsaslide lang siya. Kaya lang, kapag tinulak mo ng tinulak, bibilis siya, diba? Kita naman, bibilis siya. Kasi meron tayong constant net external force, which is our hand, no? And pag naman opposite, the velocity, babagal, di ba? Naalala niyo yung dati sa kinematics. Kapag opposite yung direction ng acceleration sa velocity, magbabago magsaslow down yung object until it stops, di ba? Ano pa napansin niyo dito? Acceleration this way, force this way, no? Pareho sila ng direction. Ganun din dito. Force this way, acceleration that way also. So, pareho sila ng direction. So, the acceleration of an object is directly proportional to the net force acting on it. It is inversely proportional to the object's mass. Tapos, in direction acceleration is the direction of the net force acting on the object. So, F equals ma, no? F equals ma. That's the key. Tapos, di ba, vector si force. For every component, gumagana siya, no? Gumagana yung ma. For every component, gumagana yung ma. Always remember that. I will show a demonstration naman mamaya, no? Okay, sige, let's see. Kapag mas mataas yung mass, mas mataas yung force needed to cause an acceleration. Kasi, di ba, ma, sobrang laki ng force na kailangan. Kaya rin kanina, it's the higher the mass, the harder it is to change its state. Dahil dito yon, mass times acceleration. Okay, always remember that. Next, estimate the net force needed to accelerate at 1/2 g. Sige nga guys. Game. Try this out. I'll give you 5 minutes, no? 5 minutes. Ang 1/2 g is 9.8 meters per second squared, no? So, yung acceleration niya, 1/2 dito. Okay, sige game. Net force needed to accelerate. Itong mga object na to at this acceleration. Game. Five minutes, Of course, sa physics, parating kilograms, no? Parating kilograms. Yes, newtons. Kasi, force, no? Force. Parating force is in newtons, no? Tama. Good job. Johan. Good job. Yes, tama yan, Julian. Good job. Sige, I'm going to wait 2 more minutes. Sige, last 1 minute. Kailangan guys ha. 21 minute. Wait lang guys ha. Okay, sige, let's discuss. Game, simple lang yan, no? Simple lang yan. Letter B, mali, Mike. Sige, let's see, ha? Game, ganito lang yan. F equals MA, no? MA. So, for letter A, 1,000 times 1 half G, 1 half times 9.8. So, mga 4,900, no? Or 5,000 would do. Next, 200 grams. 200 grams. MA pa rin. Grams to ha, baka akala nyo G ito. Grams to ha. Hindi yan acceleration due to gravity. Grams yan ha. So, letter B, convert to kilograms, 0.2 times 1 half times 9.8. No? We will get 0.98 newtons, no? Or around 1 newton. O, sige nga, guys. Oh, I'm going to test you. Ito, ano to? Um, Test kung naalala niyo pa yung kinematics niyo. Sige, 5 minutes ulit. Ang kailangan nyo, mass times acceleration, di ba? Paano nyo kukunin yung acceleration? Yun na lang, no? Mass times acceleration. So, get the acceleration first, then get the net force, no? Yun na yun. Okay. Convert to meters per second muna. Okay? Important yun. Sige, go. Let's see, Mali. Hindi. Hindi eh. Sige, it's okay. 2 minutes. One minute, sige. Okay? Sige, let's discuss. Please look at the board. Okay, man. Diba? Ang tanong is, average head force required to bring a 1,500 kilogram car to rest from a speed of 100 kilometers per hour within a distance of 55 meters. So, kung naman, di ba, acceleration, di ba, Vf squared equals Vi squared plus 2AD, no? Yun yung pinakamaganda kasi. Kasi meron ka distance, meron ka initial and final velocity. So, 0 equals 100 kilometers per hour plus 2AD. A equals 0 minus 100 over 2 times 55, no? I'll convert this to meters per second. Negative 100 kilometers, di ba? Times 1,000 over 3,600 over 2 times 55. Solving, we get negative 0.25 meters per second squared, no? Negative. Ngayon, tapos na. F equals MA. 1,500 times teka, parang may mali O sige. Anyway, let's continue. Times acceleration. Teka guys wait lang, may mali Teka, sadali lang Teka, let's repeat our conversion. No? Negative 100 kilometers per hour times 1,000 km per meter over 3,600 seconds per hour. What? Alam ko na saan ako nagkamali, guys. Ito. Squared. Squared. So, ulitin natin, Negative 7. Negative 7. Plus negative 7, no? Negative 7. Equals to 10,500. Newtons. Or around negative 11,000 newtons. Kasi 2 sig figs lang yun nandyan sa problem. Okay? Sige. I hope you get it. Pakisabi pag hindi, no? Pakisabi pag hindi. Nakuha ba before we continue? It's just a review of the concept ng kinematics. Okay, sige. Ah, sige. It's okay. Ayun, sige, it's okay. No, it's okay. Sige, next. Law of action-reaction. This is the third law of motion. As we'll get into problem solving a little bit soon. Law of action-reaction. When one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first. So, ayun, action, if object A exerts a force on object B, action, then object B exerts a force on object A, reaction. These two forces have the same magnitude but are opposite in direction. No? Take note that these two forces act on different objects. Okay? Different objects. To every action, there's an equal and opposite reaction. So, yan, example, no? Example. Diba, mayroong bola. Kaya na, yung bola, mag-exert din ng force. Pupunta sa shoe mo. Kaya kapag may sinipa ka, diba, minsan masakit. Dahil dun yun sa force na ine-exert ng bola sa'yo. Okay? Always remember that, ha? Ito naman. Ayan. Ito, moving a sled, no? Ang daming action-reaction pair, tatlo. Friction force on sled exerted by ground, force on ground exerted by sled, di ba? Dami. Kaya yung ground, kapag may hinila ka, umiinit, no? Umiinit siya. Kasi merong ine-exert the force yung ground sa'yo, meron din ine-exert the ground, yung force yung object sa ground, no? Just as that. Kaya ka rin hindi nadudulas, no? Kaya ka din nadudulas, no? Kasi merong force on the floor that keeps you there, no? That resists from sliding, which is the friction, no? Ayan. Yan, nasabi ko na lahat yan, no? Take note na they don't act on the same object, no? Parating different. Baka may paradox, no? Pero next time, I'll get back to you on that, no? Kasi may paradox to eh. Ayan. Ano dito yung action-reaction pairs? Ito hindi, no? Yung F of the table on apple and F of the earth on apple o yung gravitational force sa apple can't be an action-reaction pair kasi they act on the same object. On apple. Pag ganun, di siya action-reaction pair, no? Ito, action-reaction pair ito kasi we have the force of earth on apple, which is the weight, and force of apple on earth, which is the gravitational force. Kung naalala nyo sa grade 7, I'm sure meron kayong ginawa nito. Force of yung gravitational force ng earth and an apple, no? I'm sure meron kayong activity na ganun. And this is ito yung action-reaction pair for that. Ito naman, between that apple and the table naman. F of table on apple, F of apple on table. Ayan na magkaiba. On. Magkaiba yung ganon, no? Ito naman, letter D. Tatanggalin natin yung table, no? Tapos meron tayong tatlong forces. Wala na to. So, ito na yung meron. F of earth on apple, F of apple on earth. Yan lang yung action-reaction pair, no? Yan lang yung action-reaction pair. Okay? Pero itong dalawa, hindi ito action-reaction pair. Kasi on apple pareho, no? Yun. Always remember that, ha? Last one. Action-reaction pair. R on M, rope on mason, mason on rope. Yes. Brick on rope, brick on rope, rope on brick. Yes, yan, di ba? Itong dalawa, hindi siya action-reaction pair because they act on the same object, no? Tapos, ayun, ganon. Okay, sige. Next, mass and weight. Ayun, for those na nakamiss kanina, ito na ulit. Mass is the measure of the inertia in an object. The higher the mass, the harder it is to change its state. The higher the mass, the higher the force needed to cause acceleration. Kaya sabi ko kanina, mas mahirap i-push ang truck kaysa sa bola. Next, kaya pag napunta tayo ng moon, hindi nagbabago yung mass, no? Kasi measure of matter lang yun, measure of inertia in the object. Itong weight, it varies depending on the location, no? It varies depending on the location. Siyempre, pag mas malayo ka sa Earth, mas mahina yung pull ng gravity sa'yo. Mas balit yung value ng G. So, gravitational force is the force due to gravity that pulls an object towards the center of the Earth. Present all the time yan, guys. Ha? Present all the time. So, kapag gumagawa tayo ng analysis, parati siyang present. Weight equals mg. I'm sure sa familiar naman to sa inyo. Yan, kita nyo naman. Ito, meron nang pumipigil sa kanya. May tension force. So, pero kahit ganon, meron pa ring weight na nag-a-act on it. Diba? O, sige nga guys. O, game concept check. Sige nga. Let's see if gets yung ibig sabihin na yung mga pinaggagawa natin. I'll give you another 5 minutes. Okay. O, kakasabi ko lang, no? Pag N yung binigay, ito, it means na yun yung weight niya, no? Diba? Weight yan. Yung 2.45 times 10 to the 4th. Okay? Weight yan ng truck. Pag meron kayong nakitang ganyan, most probably, ibig sabihin yan, weight, no? Ayun. And, nga, pagkakamali ko rin, I didn't state, I'm sorry. Hindi. Hindi. Sorry. Mm, um, Erin, I think nagkamali ka lang sa calcu, pero you're there eh. Nandyan ka na. Ang sagot kasi sa book, negative 7.2 eh. Check mo. I'm sure you're near. No? I'm sure you're near. Sige, 2 minutes. Baka may nag-chat dito. Hindi Julian eh, mali eh. Sige nga, try ko ulit ha. 2 point. Oo, ano? Yes, tama pala yun, Erin. Tama yan. Mali yung book. Okay, sige. Okay, sige, let's discuss. Oh, game ha. Sige, let's look at the whiteboard. Oh. Mass times acceleration, di ba? To get the acceleration due to the net force. Pero, wala tayong mass. So, paano makakuha yan? Di ba we have the weight, which is 2.45 times 10 to the 4th newtons, di ba? Di ba weight equals mg. M equals weight over g. So, 2.45 times 10 to the 4th over 9.8. We would get 2,500 kg. Yun yung mass. Next, force equals mass times acceleration. We need the acceleration. 2,005, 2. Ano ba to? Negative 1.8 times, negative 1.83 times 10 to the 4th. Newtons over 2,500 kilograms. Ang makukuha mo dyan, negative 7.32 meters per second squared. Okay? That's good. Good job sa mga nakakuha. Yan, sige, go. Next. Ito na. Next is friction. No? Friction tayo. The friction force is a contact force exerted by a surface on an object which it is in contact with. Acts parallel to the surface of contact. Diba sabi ko nga kanina, opposite to where the object is moving. So the friction force is always perpendicular to the normal force. Ayan, no? Pansin nyo. Kaya nagkaka-friction in normal force kasi ayan no, kung i-magnify natin yung block tsaka yung floor, hindi siya smooth, no? Hindi siya smooth. Yung block natin mismo, hindi siya perfectly smooth. And yung and yung floor, hindi na siya perfectly smooth. Kaya nagkaka-friction, no? Dahil sa rough surfaces. Kaya sa mga problem, pag napapansin nyo, sinasabi kong frictionless yung floor, kung smooth yung surface. Para we have the right assumptions when solving. Kinetic, may dalawang klaseng friction, kinetic tsaka static. Kinetic friction, by the way, pag nagsusulat ka ng force, ng free body diagram, Oh, wait lang. Okay, balik susunod ka ng free body diagram. Example, dito ka nagpo-push or pull, yung friction, the other way around, no? The other way around. Tapos, normal force, parati perpendicular, di ba? Always remember that. Sige. Kinetic friction acts kapag gumagalaw yung objects when an object slides over a surface. Mu k is the coefficient of kinetic friction. No need to memorize. Given yan parati sa problem. And n is the magnitude of the normal force acting on the object. Paano makukuha yon? You will see later. Okay? Static friction, may friction kahit hindi gumagalaw yung object, no? Para hindi gumalaw yung object and hindi mag-slide yung object to make it stable. Mu s is the coefficient of static friction and n is the magnitude of the normal force acting on the object. Kaya lang, as long as yung friction force or yung applied force, no? Applied force, yun, as long as yung applied force natin is less than or equal to the static friction. Kasi ito guys, max static friction to, max static friction. Kumbaga, kung yung force mo, mas malakas dyan, gagalaw na yung object, no? Yan. So, an object will not move as long as the magnitude of the static friction caused by an exerted force does not exceed the maximum static frictional force provided by the surface. Kasi, pag naglikay tayo ng pag nag-push tayo ng object with this amount of force, meron ding friction that will act upon it, which is also static friction, equal to that applied force. So, as long as yung applied force na yon is less than the max static friction provided by this formula, your object will not move. Tapos, once the value of friction exceeds that, the object starts moving. Tapos, yung magnitude of the friction provided, pareho yun palagi, we will see an example para mag-gets nyo, is equal to the friction provided by the surface, mu k times n. So yan, this is a diagramical representation. No applied force, so no friction sa una. Tapos pataas yung friction, di ba? Pataas yung friction. Kasi weak applied force. Friction is equal to the applied force. Next, ito na, nakarating na dito, magsislide na yung object kasi equal na eh. Pero hindi pa kasi equal pa. Yun yung maximum. Lastly, magsislide na yung box at constant speed. No? Mu k times n. We will look at an example right now. You don't need to memorize this. Game. Look at the whiteboard na lang. Look at the PowerPoint for the given. Magdodrawing na ako ng free body diagram. Look this is how to draw your free body diagram. So sabi sa problem, pinupull siya towards the right, pinupush yata towards the right, no? So yun yung FA, okay? Applied force. Ganito lang kasimple mag-drawing yan. Normal force. Wait. Actually, kahit nga ito, N lang eh. Friction. Okay, ano pa given? Mu S equals to 0.40. Mu K equals 0.30. Will the box move? No? Determine the force of friction acting on the box if a horizontal applied force, if A is exerted on it of magnitude 0. Pag 0, hindi gumagalaw, so no friction yon, no? Tama ba? Wait lang Teka guys Sorry. Ayan, oo nga. Don't, sige, we'll calculate muna yung, teka lang, ulitin ko we'll calculate muna yung required na, we'll calculate muna yung maximum friction that this can hold, no? Yun yung F max equals mu s times n. Ano yung n? Okay. Sneak peek na to sa gagawin natin mamaya. Look at the y component. Look at the y component. Hindi naman siya tumatalon, di ba? N minus W, sum of Fy equals N minus W equals 0. N equals W equals mg. No? So, equals mu s times mg. So, that is equal to 0.40 times 10 times 9.8. 39.2 newtons. Yun yung max, no? Yun yung max. Okay, next. Pag lumagpas dyan yung force natin, kailangan na nating basta meron tayong kailangan gawin. So, letter A, 0 newtons. 0 newtons. Oh, let's look at the x component, ha? Fx equals 0, di ba? Equals Fa, right? Minus Ff. Minus friction equals 0. Friction equals applied force. Ang Fa natin 0. So, 0 newtons din ang friction. Letter B, 10 newtons daw. 10 newtons. O sige, net force, applied force is 10, no? Applied force is 10. 0 siya kasi in equilibrium na siya, no? Okay. O, ganun pa rin. Equals 0 pa rin. F equals Fa pa rin, no? Equals 10 this time. Oh, hindi siya gagalaw kasi, okay, isa pa. Let me repeat that. 10 newtons applied force. Okay. Mas malaki ba to kaysa dito? Hindi, no? Hindi. So, pwede, pa rin, in equilibrium pa rin yung object kasi hindi pa siya gumagalaw. Fx equals Fa minus F equals 0. F equals Fa equals 10 newtons pa rin, no? Yon. Letter C, 20 newtons. 20 newtons. O, ganun pa rin, hindi siya gumagalaw. So, 0 pa rin. Following that, 20 newtons, no? Letter D, 38 newtons daw. 38 newtons. Oh, compare this applied force to your static friction, maximum static friction. Pasok pa rin, di ba? So, 38 newtons. And lastly, 40 newtons. Ayan, calculate mo. Oh. Mas malaki na, di ba? Mas malaki na. So, we have to get yung frictional force. Okay? Kapag nag-exceed na sa static friction yung applied force, gagamit na tayo ng kinetic friction. So, kinetic friction is this. Kinetic friction equals mu k times n. Ang n natin is mg. So, 0.40 times mg, which is 10 times 9.8. Ay, 0.30 pa na. 29.4. Take note, hindi na ito magbabago. Ito na yung kinetic friction. As long as mas mataas sa 39.2, yung yung force natin. So, there we go. Before I continue, nag-gets ba yung discussion ko on friction? Hindi masyado. Okay. Sige. Hmm. Okay, babalikan natin to. Mamaya ulit, no? Mamaya ulit. This is a sneak peek. Okay, next. Okay, malit. Kasi hindi niyo pa gets yung idea behind axis, no? Sige, game. Yun. So, for the following problems, makinig muna kayo sa akin, no? Una-una, to solve problems in dynamics, draw FBD. Number 2, examine forces along X and Y. And third, use Newton's first and second law to solve quantities. Sige, game. Tingin lang kayo sa akin, ha? Tingnan nyo lang to. Okay, tingnan nyo lang to. Switch na lang kayo between the PowerPoint and the whiteboard for the given, no? Okay. So, game, ha? May box daw tayo na 10 kilograms on the table, no? Kinig lang kayo sa akin, ha? Yung unang tanong, what is the magnitude of the normal force and the weight of the box, no? Normal force exerted by the table and the weight of the box. So, let's draw a free body diagram. Hindi pa yan free body diagram, eh. Ito siya. And weight. Yun na. Take note on next. Resolve X and Y components. Walang X component, only Y components. So, let's look at the Y components. Next kong tanong, use Newton's second and first law. Tumatalon ba yung object? Gumagalaw ba yung object? Hindi, di ba? So, sum of forces equals 0. So, ganun pa rin, parang sa vectors, no? Pag upward siya, positive. Pag downward siya, negative. Solving for normal force equals to weight equals mg. Yan. So, yung dalawa na yan equal to mg. So, calculating normal force equals to weight equals to 10 times 9.8, 98 newtons. Okay? Sige. Nakuha ba? Before I continue. Sabihin nyo na sa akin pag di nyo nakakuha. Okay, next. Ngayon naman daw, your friend pushes the box with a force of 40 newtons. Dito raw, dito. 40 newtons, pababa. So, ngayon, look at our free body diagram. Look at our free body diagram, ha? Look at meron yung friend mo raw, nag-push 40 newtons on the box, pababa. Ngayon, let's look at our free body diagram. Ngayon, meron na dito sa baba na FA, applied force, no? Applied force. We are asked to get the magnitude of the normal force. So, yan. No, let's resolve our X and Y components. Wala X component, Y component only. Pero take note, di siya gumagalaw, di ba? So, let's do our usual thing. N minus W plus applied force equals 0, di ba? So, normal force equals weight plus applied force. So, mg plus 40. Kasi yun yung applied force, pababa. So, 98 plus 40 equals 138 newtons. Before I continue, nakukuha ba? Nakukuha ba? Given sa problem. Yung mass. Ayan, given sa problem, no? Ayun. Guys, pag gusto nyo tignan yung given ng problem, i-ano nyo lang, di ba meron dyan, presentation, kayo na bahala mag-pin, no? Kayo na bahala magpindutin nyo lang yon para di ba, pag nakaano sa inyo, may tiles, no? May tiles tayo. Kaya na bahala doon. Ipin nyo yung presentation pag gusto nyo. Ipin nyo yung whiteboard pag gusto nyo, no? Okay, basta ako, I'll default pinning my whiteboard. Pag gusto nyo tignan yung given, look at the slide, no? Okay, sige, game. Next. Oh, your friend pulls upward naman. O, pataas naman daw yung force. Your friend pulls upward with a force of 40 newtons. Yan naman daw. O, balikan natin our free body diagram. O, ito naman daw. Hinihila pataas, no? Ngayon, babaguhin natin yung free body diagram natin. Ganun pa rin. Ngayon, ang applied force natin, nasa taas na. Okay, yan. Free body diagram. Next, resolve the forces along x and y. So, y component na yung meron. Kasi, again, walang x component. And ang sum nila, 0. Kasi nga, hindi gumagalaw yung object. Next. Equals n plus fa minus weight equals 0. No? Ang tinatanong pa rin sa atin, magnitude of normal force. So, solving for n equals w minus fa. mg minus applied force. 98 minus 40 equals 58 newtons. Okay, nakuha ba yun? Okay, sige, next. Next. Ito raw, guys. Ito raw. Yung daw friend mo, nilaksan niya yung hila. Ginawa niya 100 newtons. Ito, ginawa niya 100 newtons yung pag-pull niya. Diba? Naalala niyo yung weight kanina, guys? Naalala niyo yung weight kanina? Diba, ang weight is mg, which is 98 newtons. Ano napansin niyo? Mas malaki na to kaysa dito. Mas malaki na yung force na pag-pull niya kaysa sa weight. So, for sure, gagalaw na yung object, no? Gagalaw na yung object. Kaya, tinatanong sa problem, what is the magnitude of the acceleration experienced by the object? Okay? Ganun pa rin yung free body diagram natin, no? Weight sa baba, normal force plus the applied force sa taas. Ngayon, ano na yung Fy? What is the sum? Nag-accelerate na siya, no? Tapos paano? Pataas. Kasi hinila niya pataas. MA. Y. Kasi nasa Y component tayo. Equals to the sum of the forces. N plus Fa minus wait lang. Joke lang. Teka. Okay. Kinig kayo. Look. Ito pala yung isa kong tip. Bago kayo mag-solve ng mga problems, try nyo compare. Example, dito sa specific case na to, hinila ng tao pataas yung object, di ba? Hindi natin alam kung gagalaw siya or hindi. Pero based on our analysis kanina, di ba? Yung weight ito is 98 newtons. Yung pag-pull niya is 100 newtons. For sure, gagalaw na yung object. Okay. So, baguhin natin yung free body diagram natin. Di ba? Wala na sa table yung object. Di ba? Wala na siya sa table. Di ba? Wala na siya doon. So, dapat, applied force na lang, tsaka weight. Dalawa na lang this time. Okay? Yun tandaan nyo yun. So, tingnan nyo muna kung gagalaw yung object or hindi. No? Pag hindi gagalaw yung object, kailangan may normal force yun. Pag gagalaw, wala na. No? So, next, resolve x and y components, then use Newton's laws. Gumagalaw nga yung object, so let's just resolve the y component kasi nga walang x. So, using this, Fa minus weight, no? Acceleration was Fa minus mg over m equals 100 minus mg 10 times 9.8 over mass 10 equals 0.2 meters per second squared. Before I continue, nakuha ba yung logic? Oh, ito lang. Solve for acceleration dito, Julian. Oh, MAY equals FA minus weight. Oh, AY equals FA minus mg over mass. Di ba ang mass natin is 10? Solving the equation lang. Nag-substitute lang ng value. Okay? Okay na? Yun. Okay. Sige. See ya, guys. Let's see, ha. Let's see. Try nyo nga to. I'll give you 5 minutes for this. Pareho na yung concept yan, no? Para matry nyo naman gumawa ng free body diagram. Yan na guys ha, sa lahat ng ginagawa natin sa physics ngayon, importante is the concept, okay? 0.20 G is, sorry, ngayon ko na, yes, tama, 1.96, no? 1.96. Pasensya na, ngayon ko na nakita na. Sige, 2 minutes. Hindi. Sige, let's just discuss, no? Okay, sige, let's discuss. Oh, game. Let's look at the board, ha? Sige, for the rest, ako na lang siguro mag-discuss muna. Tapos, make sure na maintindihan nyo yung ginagawa ko kasi next meeting, magko-problem set discussion tayo on this. Sino ba tayo? Teka lang, ha? Tayo pala. Sige, ako na lang magdi-discuss for the rest of the meeting, ha? Yan, a 65 kilogram woman descends in an elevator. So, ayun, I'm going to draw the free body diagram. Descend, sin elevator, diba? Descend. So, pababa yung acceleration. Okay, so game. Free body diagram. Wait. Yung pataas is yung normal force ng scale, diba? Normal force ng scale. Ang binabasa ng scale is the normal force na ina-exert niya sa tao. Diba? Okay. So, during this acceleration, what is her weight and what does the scale read? Okay. So, take note, meron din siyang acceleration pababa, no? Meron siyang acceleration pababa. So, dapat, plus, F, A, no? Yun yung applied, quote-unquote, force. So, joke lang. Never mind. Mali. Oh, during this wala pala. Hindi ako nang basa. Oh, look at the x and y components. Y lang ang meron. Fy equals may kasi meron given dyan eh. Ayan oh. Ang hinap natin, what does the scale read? What is her weight? So, hinap natin yung normal force, no? Tama ba? Yes, tama. N minus W. Wait, let's see yung... Wait lang. Ay, sorry. Ang hinahanap natin is... Okay. Let me restart. Erase, okay? Sensya na guys kasi nakakalito talaga itong topic to eh. Sorry if ako rin mismo nalilito, no? Okay. What is her weight and what is the acceleration? You wait muna. Naman tanong what is her weight? Oh, sige, let's get that. Oh, mg. Yun lang. 65 kg times 9.8 equals to 637 newtons, diba? Next, then you wait. What does the scale read? So ano raw yung nababasa ng scale? Ano ba yung binabasa ng scale? Scale that reads in kg. Okay, so ang weighing scale kasi ganito siya gumana, no? Kinukuha niya yung normal force, tapos based on that normal force, kinukuha niya yung mass mo. So sige, let's resolve this one. Oh. F y equals may n minus w. No? O solve for n. So ma is 65 times ito. Acceleration is 0.20 g. Plus weight, 637 over m, 65. C. $11.76 newtons. Diba? Okay guys, let me skip this. May mali eh. Let me skip this problem Pasensya na. Let me skip this problem, okay? Skip ko lang to Problematic siya eh. Okay? Balikan ko na lang siya next meeting. Oh. Ito naman, paano pag ganito? Look at the given na lang muna, no? Yan. So, calculate the acceleration of the box and the magnitude of the upward force exerted by the table on the box. Normal force yung hinahanap dito. So, ito naman. Sige, let's see Let's look at the board na lang for now. Pasensya na yung kanina. May problematic siya. Ulitin ko na lang next time. Oh. Yan, meron daw humihila na may angle na 30 degrees. 40 newtons. No? Ang mass ng box is 10 kilograms. So, draw the free body diagram. Draw the free body diagram. So, ito na. Dito na medyo nagko-complicate to. Weight, normal force. Tapos, meron dito. Applied force, no? Applied force. FP tayo pangalan. 30 degrees, no? Yan, pag meron ng mga angle, ganyan mag-drawing na free body diagram. Okay, what's next? Calculate the acceleration of the box. Okay, calculate the acceleration of the box. So, ang mangyayari dito, saan siya gagalaw? Papunta lang sa right, no? Papunta lang sa right. Wala naman sinabing ni-lift up niya, no? Wala naman sinabing ni-lift up niya. So, tama lang na sa wait lang Okay guys, ito. Look Ayan, di ba? Game, let's examine yung mga components natin. Let's examine yung mga components natin. Game. Unang-una, tanongin natin, saan siya gagalaw? Towards the right lang ba? Or paakyat din gagalaw? Let's compare muna. Ano yung weight? This is 10 times 9.8, 98 newtons, di ba? Ngayon, kasi meron tayong pulling force di ba? Of magnitude 40. Ngayon, kunin natin yung component yan na pataas. Yung y component nito. Bakit? Para malaman natin kung aakyat ba yung box or hindi. Game FP, y component, di ba? Sin 30 equals 20 newtons. Mas maliit kaysa dito. So, hindi siya may hila pataas, no? Hindi siya gagalaw sa y-axis. So, sa x lang siya may acceleration. Okay? Sige, let's see. Let's resolve our components. X and y components, di ba? Let's start with the x component muna. Kasi, fx equals to max. Wala namang ibang component Yung x component lang nito. FP cosine 30. AX equals FP cosine 30 over n, which is equal to 40 cosine 30 over m over 10, no? So, solving that, we get 2 square root of 3 or 3.46 meters per second squared. Yun yung acceleration ng box. Diba? Ano pa yung tanong sa atin? Let's see Magnitude of the upward force exerted by the table on the box. Normal force daw, normal force. So, sige, let's look at the y component. Burahin ko na to, So, y component, hindi naman siya nag-accelerate, di ba? Na-conclude natin kanina. So, 0 equals to n plus y component nito minus weight. Solving for n, -98 minus 40 sine 30, which is 20, 78 newtons ang ating normal force. Yan, no? Ulitin ko lang, sa x, dyan lang tayo nagka-acceleration kasi kinompare nga natin kanina, di ba? Yung y component, itong pulling force natin sa weight para malaman natin kung mahihila ba pataas or hindi. Hindi naman kasi mas maliit. Tapos, resolve our components na. Sa fx, max equals fp cosine 30 lang. Wala na kasi ibang x component, no? So, there. Acceleration is 3.46. Tapos sa y component naman, di nga siya gumagalaw, di ba? So, n plus fp sine 30, which is the y component of this one, minus weight equals 0. So, solve for n, we get 78 newtons. Please, sabihin na sa akin pag meron kayong digits, ha? Sorry na if medyo magulo kasi mahirap yung di-discuss natin. Next, tension. Tension in a flexible cord. So, paano naman yan, no? So, ito na. Ito na yung sinasabi ko kanina na minsan, meron dalawang system or dalawang object na may magkaibang free body diagram in one problem, no? Sige, ito muna. Two boxes, A and B, are connected by a lightweight cord and are resting on a smooth frictionless table. The boxes have masses 12 and 10 kilograms and a horizontal mass. A force of 40 newtons is applied to the 10 kilograms box. Find the acceleration of each box and find the tension cord in each box. Find the tension, no? Okay. So, ito na. Dalawa yung free body diagram natin. Yung isa, para sa mass B, di ba, weight niya, normal force niya, tsaka tension. Di ba? Kasi yung cord, pag ganun, di ba, sabi ko sa inyo, palabas parate, no? Palabas parate. Tapos ito rin, no? Sa A naman, ito yung applied force niya. Ito yung tension niya, palabas, di ba? Tapos meron siya normal force, tapos meron siyang weight, no? So, yun yung forces acting on it. Tapos, the system is connected by a flexible and massless cord. Di ba? Naka-specify dyan. So, dapat, di ba, tinatanong what is the acceleration of each box? And ano yung tension? Okay. So, dahil flexible and massless yung cord, dapat pareho lang yung acceleration nitong dalawa, no? Acceleration of each box, dapat pareho lang yan. Okay? Pareho lang yan. As long as they're connected by a cord. Next, magkaiba ba yung tension nitong dalawa? Hindi. Kasi isang cord lang yun, guys. Isa lang naman yung cord, hindi naman nagbago, no? So, dapat pareho lang yung tension na makukuha natin. So, solving, look at the board. Dire-diretsuhin ko na, no? Mass B. Free body diagram. Normal force. A. Weight. A. Applied force. Tension. Malakihan ko pa. Sa B naman, ganoon din, no? Napansin nyo, wala ito sa B. Diba? Wala ito sa B. Kasi, yung applied force, nakakonekta lang sa A. Sa A lang siya nakakonekta, diba? Yun. Sa A lang siya nakakonekta. Kaya hindi siya kasama dito. Weight B. Okay, game ha. Ngayon, I'm going to write equations for the both of these. Ang kailangan lang natin is yung x component. Diba? Yun ang importante sa atin. Kasi, yun lang naman yung hinahanapan natin di ba? Yun lang naman yung hinahanapan natin Yung hinahanapan na natin is acceleration and tension. So, we don't care about the y component. Kasi hindi naman siya gagalaw doon. Kasi pa-horizontal lang yung push, ay yung pull, di ba? So, let's look. Sa A, FA equals MA equals to applied force minus tension. Sa B, FB, X lang to equals MAB equals tension. Diba? Ngayon, diba equal yung, by the way, MA to, MB, kasi magkiba sila ng mass. Diba equal yung acceleration nito? So, palitan ko na sila. MA lang, MA. Okay. Solving system of equations. I-substitute ko to dito. MAA equals FA minus MAB. Ay, minus MB times A. MA, A plus MB, A equals FA. A equals FA over MA plus MB equals to, ano ba yung nakasulat dyan? 40 newtons over 12 plus 10, no? Masses naka-given doon. So, this is equal to 1.82 meters per second squared. Yan, next. Sa letter B naman, find the tension. Alam natin yung acceleration, so ipasok na lang natin dito. Dito sa equation na to, no? So, acceleration times the mass of B, which is 12, equals 22 newtons. Yun ang tension natin, no? Yun lang. Or 21.8, no? Please, sabihin nyo sa akin if nalito kayo or hindi nyo gets at all, okay? Next, magbibigay na ako ng optional homework ulit, no? Para matry nyo rin. Ito, more problems in friction. Same problem sa kanina. Kaya lang ngayon, meron ng friction. So, paano yan? Game. So, nakasulat na dyan, gagalaw yung box, no? Gagalaw yung box for sure. So, let's do our precautionary check. Ano yung weight? Kasi hinihila rin siya eh. Weight is 98 newtons, di ba? mg. Meron tayong ganun ulit. Hinihila siya, di ba? 30 degrees sa angle. 40. Looking at the vertical component, yung paghila sa taas, it's less than this one. Kasi sine 30 is 20 newtons, di ba? Way less. So, hindi siya gagalaw pataas, no? Only to the right, no? So, okay, let's see. Let's draw our free body diagram now. FP, normal force, weight, tapos, friction, yan na. Diyan na pumapasok, no? Diyan na pumapasok yung friction. Okay, what's next? Oh, sa x-component muna. Sa x-component muna tayo. Nag-accelerate siya along the x-axis. MA x equals, right? So, FP cosine 30 minus F. Okay, ano yung F? Mu K, coefficient of friction, times the normal force. Saan to makukuha? Sa Y component. Let's analyze the Y component. 0 kasi di siya gagalaw doon. N plus FP sine 30 minus weight, no? So yan, let's solve. Then we have our acceleration, no? We have our acceleration na. Game. Normal force equals weight minus FP sine 30 equals to 98 minus 40 times sine 30 equals 78 newtons. Diba? Ngayon, ipasok na natin siya dito. Kinukuha natin acceleration, diba? So, solving for A equals to FP cosine 30 minus mu K times N over M. So, solving, FP cosine 30, so 40 times cosine 30 minus mu K, 0.4. 0.4 ba? 0.3 lang yung coefficient, no? 0.3 times normal force, 78, over mass, 10. We'll get 1.12 meters per second, no? 1.12 meters per second squared. Okay, bago magpatuloy, nakukuha pa ba, guys? Or di na? Ano, kamusta guys? Mahirap ba? Saan po papasok yung friction? What do you mean saan papasok yung friction? What do you mean? What do you mean? Saan ginamit yung 0.30? Oh, 'di ba? Ang friction coefficient of, 'di ba? Ayan. Friction to get this. Ay, kung napansin nyo guys, di ako nagsasubstitute agad, no? Hindi ako nagsasubstitute ng numbers agad sa dulo na. Para madali. Para hindi ako malito, no? Yan lang yung technique ko. If you want to substitute numbers right away, go lang. Okay, friction is mu K times N. Kinetic friction siya, di ba? Kasi nga gumagalaw. Oh, tapos dyan ko pinasok. Mu K is 0.30. Yan, dyan siya pumasok, no? Okay, formula yan. Times the normal force, which we got from our Y component. Yan. Okay? Okay, sige. Marami pa akong pwedeng discuss eh. Sige. Last two. Ito yung mga special case, guys. Tana. Mahirap to, mahaba to. Last two, tapos okay na tayo. Two boxes are connected by a cord running over a pulley. The coefficient of kinetic friction between box A and the table is 0.20. Find the acceleration of the system. We ignore the mass of the cord and the pulley. So, ano yan? So, naalala niyo yung kaninang tension? Parang ganun lang din, no? Parang ganun lang din siya. So, sabi ko nga, pag dalawa yung object sa system, lahat gagawa ng free body diagram. Oh, sa A, ito yung free body diagram niya. Normal force, weight, yung tension, which is to the left, ay to the right, tapos yung friction, di ba? Kasi papunta siya sa right, so kailangan may nag-o-oppose sa kanya. Tapos sa B naman, yung tension lang, tsaka yung weight. Pareho lang yung magnitude nito. Bakit? Kasi, ang tawag dito? Pareho lang yung magnitude niya, kasi nga, same chord lang. Okay, ngayon, look at the board na lang. If you want to copy, please do. Kasi, mahirap siya i-type sa PowerPoint. Kaya hindi ako nag-type masyado ng solution sa PowerPoint. Napapansin nyo, no? Okay. Let's draw our system, no? Free body diagram. Isa akong marker. Yeah, guys, isa akong marker. Sige, okay lang yan. Sa A, ito. N, A. Weight, A. Ito. T. Para lang kasi sila ng tension. Isa pa. Pareho lang din yung acceleration nila. Okay? Pareho lang din yung magnitude ng acceleration nila. Bakit? Kasi, same chord lang sila, no? Kumbaga, connected sila by the same chord. So, dapat isa lang din yung acceleration. Pareho lang. Next, sa B naman, ito. T, tapos, weight, B. Okay? Ngayon, let's look at each component. No? Let's look at each system. Tas sa A, meron pa palang friction. Hindi ko na malimutan. No? Meron siya friction. Sabi sa problem. Okay, game. So, sa A, ito. If you want to copy this, please do so. X, pareho lang sila na acceleration, no? So, didiretso ka na. MA, A, equals to tension minus friction equals T minus mu K times N. Sa y-axis naman ito, hindi siya gumagalaw sa y-axis. NA minus weight A. NA equals weight A equals MAG. No? Mamaya ako na ayusin yan, ha? Letter B. Ito na. Nag-accelerate din siya downward. Hindi siya free fall, guys. Hindi siya free fall. Kasi meron siyang chord, no? Yung acceleration niya, kahit falling downward siya, hindi siya 9.8. Baka kala niya 9.8. Hindi, Kasi meron siyang tension pataas. Fy lang yung meron dyan. M, A. Kaya lang, pababa siya, guys. No? Pababa siya. So, dapat, negative A. Negative, no? Negative. Kasi pababa siya. Equals to tension minus weight of B. Ngayon, anong plano kong gawin? Solving system of equations na naman tayo, no? Remember this, guys, ha? Remember this. Kasi buburahin ko na. Equals T minus mu K times ito, M A G. Iusin ko to. Talagay ko dito para mas makita natin. Weight B is MBG. Okay, what's next? Obviously, ang pinakamagandang gawin, guys, is eliminate natin yung tension, no? Kasi yun ang hindi natin alam. Yun ang hindi natin alam, no? Yun ang hindi natin alam. So, let's try. Solving system of equations na naman to. Ayusin ko lang to, Subtracting both. MAA plus MBA equals to MBG minus UK MAG. Solving for A, MBG minus UK MAG over MA plus MB. Solving. Ang coefficient of friction is 0.20. Sige, last na to. 0.20 times 5 times 9.8 over MA plus MB. 5 plus 2. 1.4 meters per second squared. Tama ako. Sige guys. Yun na lang muna. Bago mag-start yung next meeting, magdi-discuss ako ng inclines, no? Yung last part to slide. Then, meron ako optional homework sa inyo, no? Yun lang, guys. Sige na, guys. You're free to go. Maraming salamat. Bye-bye. I hope you get it. You'll practice more naman next time. Okay na, guys. Bye-bye.
Bye po.